Greetings, Earthlings. Well, I'm still trying to track down the problem that I have with the memory diagnostic on the Nova 445. And one thing I did when I designed it to help in that regard was I added these headers. I don't know if you can see them very well. There's one there and there's one there. This is a memory address register, and this is just the data lines to make debugging a little easier. So you say, oh, well, pull out the logic analyzer of yours and hook it up. Well, it doesn't hook up that well to these. These are spaced at, 50 thousandths, rather than your standard header, of 100 thousandths or 2.5 millimeters. So that's the clip that the logic analyzer uses, and it just isn't practical to get those clips on there. So what I did is I found a connector that mates up with that, and I built this little debugging stick out of parts on hand. You can see it's very simple. It has a connector connected by a ribbon cable to this board. There's a, I needed 28-pin chip minimum because I have 16 data lines coming in, and then this is a serial LCD display, SPI. So 2 lines for that, 16 lines, power, ground, reset, things like that. I needed 28 pins. So what was the sort of cheapest, least capable 28-pin processor I had? Well, it's a PIC 16F 722A, left over from some other project, running at a whopping 250 kilohertz. It can run faster than that, but that's the default speed, and I don't need anything faster than that. So this will plug on. This will plug on here. Not like that. Okay, that goes on there. I have power and ground. Oh, the other thing, of course, is that I have, these little test points, call them. I put ground pins scattered about the board because you always need those when you're checking things. But I also have one that's the 5 volts, which is right there. Ground is over here. And what this does, so it's hooked up now to the address bus, and what it does is it's just going to display the value on the address bus. It's a 16 by 2 line, 16 characters by 2 line display. So on the first line, I display the value in binary, and on the second line, I convert that to hex and octal. So we'll see that. It's all zeros right now because we haven't started up. Oh, and then there's a nice little power light. That was just for debugging purposes. It tells me that I've made it through the initialization code properly. So if I get this thing running, I said if I get this thing running, there we go, and it's blinking its carry light, running that memory diagnostic, and you'll see this updates, I think it's about 7 times a second. So not very useful right now. It'll be useful when it fails. The thing I'm doing right now is looking for patterns. What information do I have? And I've noticed 2 things so far. One is that the diagnostic runs and then it will halt if it detects an error. So this is showing me the address that it halted at, and then I can look in the code, match that up with the halt instruction, and figure out where it halted. So the first question is, does it always halt in the same place? And it seems like when I run it, the first time it halts, it always halts in test 2, which is writing all ones to the memory. Of course, that's after running for quite some time, running through all the various tests. The other thing I notice is that the current draw, as indicated on the power supply, seems to go up a little bit, okay? And then if I try to continue or restart it, that's the reset button, that's the load button or run button. If I try to restart it, then it fails immediately and generally in the first test. So it gets stuck in that state. So it's feeling to me like it's some sort of latch-up situation. The memory chips are CMOS, and they do have some floating pins. I don't know if you noticed in the last video, these things stuck in there. It's dual port RAM. So one side, one port goes to the processor. The other side goes to these connectors, which would go to the, in this case, the monitor, or the graphics display. And in this case, it's a DMA bus, which would go to the disk controller. Well, those inputs are floating. What I had with these resistors is I pulled up the chip enable lines, thinking that might help. But I left a bunch of other lines floating. There's an output enable, there's a write enable, and so on. Well, it's generally a bad idea to leave inputs floating on CMOS. On TTL, you can do it, but CMOS, bad idea. So, I don't know. My best guess at this point is that it may be some sort of a latch-up situation. In any case, it's running reliably enough. It runs for, 5 or 10 minutes? I don't know. We probably won't run this video long enough to see it fail. Although I may turn the camera back on just so you can see the output of my debugging stick. But it runs reliably enough right now that I can go on and play with the video board, which that'll be another video, but that's a sneak preview there. Video boards, which I got from JLC PCB. Yeah, I'm going to now pause the video and we'll come back when this has failed and let you see what the display looks like when it's not constantly changing. Okay, it's been a few minutes and it has indeed stopped. And I can tell you, I don't know if you can see the power supply, but it was bouncing around during when it was running between 1.034 and 1.037 amps. Now, when it's halted, it's at 1.081. So that's gone up, 50 milliamps or so, pretty close. Now 1.084, 82, 84, 82. Yeah, and here's our display. I hope you can see that. Let's see what we got. 160047. Well, now, that's different because it had been stopping at 160031. This time it's 47, which is a different test. This is the address test. Okay, so what does that mean? I'm not sure. Yeah, so it requires some more thought and guesswork and debugging. The hardest part is coming up with a theory you can test to see if, maybe that's the problem, because there's not a whole lot of information. I probably will have to hook the logic analyzer up to the data lines and see at least what the logic analyzer thinks the data looks like. And then one other thing I know, some of you are probably saying, well, why don't you just build a proper front panel, with the blinking lights and the switches and all that stuff. Yeah, well, again, this was done with parts on hand. I could do a front panel, but that would be a major undertaking. This took me very little time. It's one chip, few capacitors, a resistor or two, and the LCD display, all of which I had on hand. And so I was able to throw this together very quickly. To do a front panel, I don't have that many, LEDs. In fact, my first thought on this was to just drive 16 LEDs. Well, I don't have 16 through-hole LEDs. I do have lots of surface mount LEDs, but then I don't have proper prototyping boards to build a board with that. And so, this turned out to be easier. So maybe there will be a front panel somewhere down the line. For now, this comes in handy. Okay, so I mentioned this, I can reset and restart it, and you see it dies very quickly. It did run a little bit. And now it's at 160031, which is the ones test. And again, and you see now it's running. It didn't halt, but it's not blinking the carry. That's weird. And it's showing an address of zeros. So what happened there? I don't know. It jumped to location 0 or something. Try it again. Bing, 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 and stop. And 60031. So it seems to die a lot in that one test where it tries to set memory to all ones. Doesn't seem to set to stop in the 0 test, which means that there's some value that, most likely some bit, one or more, that are one that it's reading back as 0 for whatever reason. So more investigation required.